Hey, geometry. This is lesson 733. We're going back to quadrilaterals and the coordinate grid. So we're going to use slope, distance to prove quadrilaterals on the XY plane. Let's go ahead and get started. All right, so we're going to start with another must be, could be problem. So we have some new descriptions below, and we're going to figure out what quadrilaterals it must be and what quadrilaterals it could be. So the must be is always above the could be quadrilaterals in our family tree that we talked about in lesson 726. And so my quadrilateral has 3 right angles. Obviously no quadrilaterals have just 3 right angles. So which ones have at least 3? So probably just 4. 4 right angles. If you're thinking rectangles and squares, that would be correct. Rectangles goes above squares in the tree, so all squares are rectangles, but not all rectangles are squares. So for part A, the must be would be the rectangle, and the could be would be a square. All right, and then in part B, my quadrilateral has a pair of parallel sides. So I always think parallelogram when I hear parallel sides. The shapes that are also parallelograms are a rhombus, a rectangle, and a square. So for part B, it must be a parallelogram. And then it could be a rectangle, rhombus, or square. All right, and then part C, my quadrilateral has 2 consecutive equal angles. Consecutive means that they're side by side, not opposite. So it's not going to be a parallelogram because those equal angles are opposite of each other. But it could be a rectangle, could be a square. An isosceles trapezoid has 2 equal angles next to each other, those base angles, any right trapezoid. So since those don't really fall into the same category, not all isosceles trapezoids are right trapezoids, there is no must be for part C, there's only could be's. Sorry, my dog's barking in the background. All right, and so in this next problem, we're going to look at 3 different types of quadrilaterals, and we're going to figure out if the quadrilateral has a special name, and we're going to be able to prove that it is that quadrilateral. And so to do that, we just need to know what are the definitions of each of those quadrilaterals. And that should be in, I believe it's your 7 to, sorry, I'm looking them up real quick right now. Yeah, 723 notes has all the definitions of the quadrilaterals. So quadrilateral is a 4-sided polygon. A kite has 2 distinct pairs of consecutive congruent sides. A trapezoid has at least 1 pair of parallel sides. So always look at those notes. Maybe put like a sticky note on there so that you know to look for those. All right, so I went ahead and I graphed each of these each of these lines to kind of save us some time. So remember that this number is where we start. So I started at 3 on the graph, the y-intercept, and then this is the slope. So this is what we use to graph the next point. So we go down 3, and over 2, and that's how I got that next point right there. All right. And so to me, this kind of looks like a rhombus. So we're just looking at this shape right here in the middle. This shape right here. So that kind of looks like a rhombus to me. It looks like it has all equal sides. So I'm going to say rhombus because all 4 sides are equal, or you could say are congruent. All right, and then we're going to prove that all those sides are congruent. The shortcut to do this is to count the slope. So from this point to this point, we go up 3 and over 2. And so to find the hypotenuse, we would just do 3 squared plus 2 squared equals c squared. All right. And so then for the next side, we would do the same thing. We're going over 2 and down 3. So we would still be doing 2 squared plus 3 squared to get c squared. Okay. And then again, if you notice, they all have the same base and height of that right triangle slope. So again, this would be 3 squared plus 2 squared equals c squared. And then again, we have over 2 up 3. So that would be again 2 squared plus 3 squared to find the hypotenuse squared. So we know that all sides are going to be congruent. Because we know that 3 squared plus 2 squared is going to equal 2 squared plus 3 squared, and so on. So we don't have to actually solve for c. That's kind of my shortcut, is not actually solving for c, but showing that plugging in the legs, or the base and the height for each of those slope triangles into the Pythagorean theorem, we would get the same c, because it's basically the same formula. All right, and then part B, I went ahead and graphed the points on there. A is at 0, 2, B is at 1, 0, C is at 7, 3, and D is at 4, 4. So we're given all those points. I obviously see a trapezoid there. Something that you might or might not see is that it kind of looks like a right trapezoid, because these kind of look like right angles to me. So I'm going to put that this is a right trapezoid. Oops. And then, because the definition of a trapezoid is that one pair of sides are parallel. So I'm going to prove that AD is parallel to BC. Those are the two sides I'm going to prove that are parallel. And then also angle A and angle B are right angles. So I'm going to add an and one pair of consecutive right angles. So I'm going to also prove, so it's kind of my first part. My second part is proving that angle A and angle B are equal to 90 degrees. In other words, I'm going to prove that AD is perpendicular to AB and that AB is perpendicular to side BC. Because if they're perpendicular, then they cross at 90-degree angles. Okay, so first off, AD and BC. In both of these, I need the slopes to prove that two lines are parallel and that two lines are perpendicular. So I'm going to use the slopes. So for AD, the slope is up 2 and over 1, 2, 3, 4. So 2 over 4. And I can always simplify that to 1/2. And then for BC, this slope is up 3 and over 1, 2, 3, 4, 5, 6. So that's up 3 and over 6, which also reduces to 1/2. So proving that those slopes are equal, that proves that the lines are parallel. Slopes are equal. All right. Whereas proving that the lines are perpendicular, the slopes need to be opposite reciprocal. So I already know that AD is 1 over 2. I already know that BC is 1 over 2. And so that means I need to prove that line AB is -2 over 1 for that to be opposite and reciprocal. And so if you count from A to B, it is down 2 and over 1. All right, so that does mean that they are perpendicular. So slopes, I'm just going to write a little note in the bottom so you guys know. Slopes are opposite and reciprocal, or reciprocal means flipped. All right, in our last shape, I went ahead and graphed W, X, Y, and Z on there, given their points 0, 5, 2, 7, 5, 7, and 5, 1. And so it kind of looks like it could be a kite. So I'm going to write down that it's a kite because, and that definition is two both pairs of consecutive sides are equal or congruent. All right, so I'm going to try to prove that this side is equal to this side and this side is equal to this side. All right, so first we're going to try to prove that WX equals XY. So XY is pretty easy. You just count 1, 2, 3 since it's horizontal. So that length is 3. To find WX, we're going to have to use Pythagorean theorem. So 2 squared plus 2 squared, since the sides are 2 and 2, equals C squared. Well, 2 squared is 4, so 4 plus 4 is 8. And to get C by itself, you just have to square root both sides. So square root of 8 is not equal to 3. So those two sides are not equal to each other. So I can't say that it's a kite, but what I could say is that it's just a quadrilateral because it has 4 sides. So for this one, this quadrilateral does not have a special name.